is, if I place, what happens if I placed a negative charge? If I placed a negative charge minus Q naught in the field produced by, whether it is a positive charge, field produced by a positive charge or by a negative charge. We have seen in the previous slide, children, that if we place a positive charge, that the positive charge will move in the direction of electric field. In the direction of electric field. But now, if the charge is being replaced by, positive charge is replaced by a negative charge, this one.
It'll move inwards.
Definitely, this minus Q naught, it is a free charge, and it will, as per the Coulomb's law, there will be a force of attraction. So it will go inwards. And if the same charge is placed here, now please check. If I place this charge minus Q naught here, then it will go out. It will go outward, that the repulsion will be there. But the concept that I want to tell you that you should remember, children, and this is if minus Q naught charge is there, this one. If minus Q naught charge is placed in an electric field, then this negative charge particle always move opposite to the direction of electric field lines. Let me write here. Negative charge moves opposite to the direction of electric field. Opposite to the direction of electric field. Is this really happening here? You can see here that the direction of electric field is outward. Electric field is outward. But here the charge particle, you can see that it is going inward. And in the second case also, electric field is inward. But what is the direction of the charge particle? Negative charge particle is going away. That you should remember, children. Why we need to remember this point? Because electric field is a vector quantity. So we should remember that the direction, in what direction that the charge particle will go. Now, children, here that this diagram, these patterns, you need to remember. And what are these patterns here? In the first diagram, in the first picture, children, you can see we have two positively charged body. The one positive charge, other one is also the positive charge. So when the one positive and other positive is placed closer to each other, what about the electric field patterns? These patterns come in the exam, children. This comes in your exams in IGCSE and in your competitive exams. So this positive and positive charge, what type of patterns will be there? If the charge is opposite, one is positive, other is negative, what type of pattern? You have to make almost such type of pattern, children. And what happens when we have charges are produced, positive charges are produced, uniform charges are there on two parallel conductors. This is the negative. The negative charge is there. Uniform charges are there. So this pattern, children, you have to draw carefully. Now,
So why are the arrows towards the negative?
Yeah, let me draw by myself, students. It's not that you need to draw exactly the same diagram, but suppose if I am a student and if I have to draw this diagram in exam, so how will I draw? Please see here. Positive charge, positive charge. So in positive and positive charge, what will happen?
Repel.
Yeah, they will repel, definitely they will repel. The pattern will be, but the thing which you have to remember, that the sign of arrow, it should be outward, children, because we are taking the positive charge here. So any number of lines you can draw, that any number of lines, it doesn't matter how many curves you draw. So how many curves you want to draw, that's it doesn't matter. If you draw this diagram, that still your answer is correct. This is enough, you will get the 1 mark out of 1. But in the second case, if one is positive, that one student asks, if one is positive, other is negative, then what will happen? Then what will happen? So you can draw the diagram slightly in this way, that this electric field lines from the positive, this is outward, the line is going outward, and the same line for the negative, this is inward. For the negative, it is inward. Similarly, you can draw in the downward also. For the positive, the sign of arrow should be outward, and for the negative, that the sign of arrow should be inward. And similarly, you can draw so many lines. And I want to draw one more line from positive to negative. Electric field lines, they originate from the positive and they terminate at the negative. So even I can draw this line here for the positive outward and for the negative inward. Always put the arrow sign in pair, that one should be for the positive and one for the negative. For the positive outward, for the negative, you can show by the inward arrow. And even so many lines you can draw, children. And similarly for the negative, this will be inwards. This is enough. If you draw this diagram, still you will get 1 out of 1. Not necessarily that you need to draw the exact diagram that you have seen in your textbook or in the previous slide. And that you can see. Remember that in your textbook, we have only the diagram when the one is positive charge, other is negative charge. But by chance, if you find that if you have to draw the diagrams when both are positive, then you can see here in this diagram. And the third diagram shows that if the charge is uniformly distributed on the two parallel conductors, that this third picture here. So the field will be uniform parallel lines starting from the positive and terminate or end at the negative. Starting from the positive means their origin point is positive, they originate from the positive charge and end at the negative charge. Yeah, that's enough for the day, children. Now I want to pause this video.